Recordings rolling. It is Monday, December 15th. Gonna do a few review calls with you guys. Remind you guys how the midterm calculation works, which covered last week, but one more time. And then on your desk, you guys have one of these booklets. I'll have you guys make a flip book later in class today. So, yeah, let's look at this midterm calculation. So this should be universal for all your classes. Your semester grade, here's how you calculate from your quarter grades and your midterm. Your midterm that you guys are going to take this week is 20% of your semester grade. Okay. And so you can calculate that. Or if you want to target a specific grade, like I want to get at least a B, that would be at least an 80. Right? What do I have to score on the midterm? And that's what this is down here. And then I gave an example in pinky how to do that. With that, the schedule this week. Right, so today's a regular day. Tomorrow, you're going to have a long first period for your first period or semester exam, your midterm. And then you'll have shortened classes. We're going to get out at 3:30 tomorrow. Each day after that, you only go to a couple of classes, 2, 3, 4, 5, and 6, 7. And we're going to get out at 2:30 each of those days.
Wait, each of what days?
Wednesday, Thursday, Friday.
So you get out at 2:30?
Yep. Huh?
Where do we go on Friday?
6 and 7 on Friday.
Oh.
Yeah. Right. So, yes, this is posted on Google Classroom from a long time ago. A few weeks back. All right. So, yeah, let's solve some puzzles. Do some practice puzzles here.
Yes, sir.
Okay, so, this one, top left. Guys, what's the equation of this line? You got some paper in front of you? Write this down. What's the equation of this line right here? Say y equals or f of x equals. Either way. Guys, let's go slope intercept form. Slope intercept. What's the intercept right there?
10.
10. Yeah, the y-intercept is over 10. Guys, what do you think the slope is?
It's 5. Negative 5.
Yeah, 2. Guys, you're going up 2 over 1. Or you could say up 10 over 5, but that reduces to 2 over 1, doesn't it?
Yeah.
So 2 x plus 10. I think that's it. That's the whole thing. All right. What if you weren't sure? Guys, could you make a table of x, y values? We've done this over and over, right? Okay. Let's try negative 5. Let's try it 0. Let's try it 5. See what happens. Right. If you plug in negative 5.
Negative 10.
Yeah, you get negative 10 here. Plus 10 brings you to 0. So this should be a coordinate. Negative 5, 0. Is it? Oh, yeah. It's right there. Negative 5, 0. That's totally a coordinate. What if you plug in 0? What do you get?
10.
Yeah, it comes out to 10. Which would be the y-intercept? Yeah, 0, 10. That's that point right there. What if you plug in 5? What do you get? 10 and 10 make 20. So the point 5, 20. 5, 20. That's like right here. Yeah.
Dang.
That's 520. Right. First, you can keep going. Hey, you can always do that. Right, how about this piecewise? You guys remember how to make it piecewise?
Nope.
Right, well, that's what we got repeat for. Okay. So it scales this the same. I'm scaling it by 5s.
Less than negative 5.
So I'll say f of x equals big old curly bracket. Now let's think we have 3 different scenarios on different domains.
Hey,
Here, guys, taking notes here.
Yeah.
Oh, so let's go left to right, guys. What's the equation of just that bit right there that you're seeing?
Oh.
Huh?
0.
0.
Less than or equal.
If it's less than negative 5.
Yeah, that's looks like less than 5. Strictly less than 5.
Yeah.
Right. So I put a little open hole right there. Yeah. Okay, so that's the first part. Right. What about this middle part right here? Okay. So what's the equation of that line? Does it have the same slope as this one we just did?
Yeah.
Yeah, it looks like up 2 over 1 or up 10 over 5, same thing. Right. But now this has a y-intercept of what?
Negative 5.
Negative 5. So could that be 2x minus 5? And you could check your work with the table if you want to, but that's what it would be. Okay. If what? If x is between what?
Negative 5 and 5.
Yeah, negative 5 to 5, but also inclusive. So negative 5 less than or equal to x less than or equal to 5. Right. Yeah, this is like tells you what part of the domain to look on for this to apply this function. Okay. Hey, how about this last part right here? What's the equation of this bit?
Y is 10 if
10.
5 is greater than 5.
Yeah, if x is greater than 5. I'm saying strictly greater than, because I'm not allowed to prove that point. Alright, you guys make it piecewise. If it. Alright. Ooh, let's do factor by grouping. Factor by grouping. Alright, so this right here. Yeah, there's probably at least 2 different ways to do this, and it'll lead you to the exact same answer. So we got 3x to the 3 plus 5x squared plus 12x plus 20. Okay. Looks like I have 4 terms. Now I could group the first 2 and the last 2. I could group first and third and then second and fourth. What do you guys feel like doing? Alright, let's do it both ways, and I'll show you that you get the same answer regardless. So what if I group the first 2 and last 2? So I got 3x to the 3 plus 5x squared as a group, plus, and then 12x plus 20, the second group. So, guys, what can you pull out of the first 2 terms?
X squared.
X squared. So it could be like x squared. And I'm left with 3x plus 5. Okay. Over here, what can you pull out?
X.
Well, they do.
X, no, 6x times 2.
Okay, guys, do both of these terms have an x?
No.
No, so you can't pull an x out.
2.
Yeah, I think 4 is the best answer. Yeah, you can pull out 2, but then you can pull out another 2. Let's go 4. Aren't 12 and 20 both multiples of 4? Okay, let's pull a 4 out. And then I'd be left with, what, 3x plus 5, I think. Is that right?
Yeah.
Oh, what is this? Yes.
They're the same.
The same thing. Ah, can I pull an x squared plus 4 out of the 3x plus 5? Makes us x squared plus 4. 3x plus 5. Okay. Hey guys, if I went back and foiled this, first, outside, inside, last, would it lead back to the original statement? Yeah, no way. You can check that. Let's try it the other way. Guys, what if you group first and third and second and fourth? Just group it differently. So, 3x to the 3 plus 12x. And then over here, I'll bring out my 5x squared and the 20. So it's just a different grouping, isn't it? All right, let's play around. Let's see where this goes. What can you pull out of the first 2 terms?
X.
How about a 3 and an x?
4x.
3x,
Can you do? Oh, wait, never mind.
right? Okay. Here I got x squared plus what?
4x, or no, 4. Yeah.
And over here I can pull a what out? 5. X squared plus 4.
Plus 4.
Oh, look at this! Look at this! Hey, it's the same thing, isn't it? Same thing.
I think we only lost.
Right, guess it? Hey, guys, get back to by grouping. Alright, divide. So I'm gonna review with guys. Everybody taking notes?
Yes.
Anybody taking notes? Probably not. Let's do long division. Let's do synthetic division. So long division. We'll do that first. Long division. So I'm gonna take this numerator, this dividend, 2x to the 3 minus 7x squared plus 7x minus 2. Okay. I'm dividing out this divisor, denominator, x minus 2. Okay. So let's go through this. Okay. So I'm looking at the first term of each of these expressions. I say, how many times can this x go into 2x cubed?
1.
2x squared. Yeah. 2x squared. Is that right? Okay. Because you take 2x squared, multiply by x, that gives you 2x cubed, which matches this. So when I eventually subtract, that'll go to 0, which you should. You're trying to make that happen. But guys, don't forget this piece here. 2x squared times negative 2. Isn't that negative 4x squared? Is that right? Okay. And I'm going to subtract this. Subtract. Oh, I could distribute the negative. Go like that. And then, of course, that zeroes out. Good. Okay. This is negative 3x squared. Okay. Then drop down to 7x, so I'll say plus 7x. Right. Then just rinse and repeat the process. Just go as far as it can. So how many times does x go into negative 3x squared?
Fucking attempt.
How about negative 3x times? Because negative 3x times x would be negative 3x squared. And then negative 3x times negative 2, that's plus 6x. Right? And then just like before, I'm going to subtract this off. I'll go ahead and distribute the negatives so I don't stumble over my negatives. Plus, plus, minus it goes. Okay. All right, so tally this up. Okay, this 4 zeros out. 7x minus 6x. I think it's just plain x, isn't it? Drop down to 2. Well, negative 2. And how many times does x go into x? Once. So today plus 1. Okay. Now, 1 times x, of course, is x. 1 times negative 2 is negative 2. Oh! Oh! What do I get?
6 ended.
0. Isn't that right there, the remainder?
Yeah.
Which, since it is 0, you can say there is no remainder. You can say that, actually. Right? And the complete answer is just this right here. So that actually divided evenly. You guys see that? Right? So here's your quotient. I just boxed it in. That's the answer. You see that? All right, guys ready to do synthetic division?
Yeah.
All right, so exact same question, just a different process, but I bet it leads to the same answer. Let's see if it does. Do you guys remember how to do synthetic division?
No.
I'm going to take these coefficients. Well, we'll do it right now. And if you're taking notes, then remember within a couple of days here, you're ready for the midterm. Take the coefficients. I got a 2, a negative 7, a 7, and a negative 2. So 2, negative 7, 7, negative 2. Right. Oh, do you guys notice that I didn't skip any powers of x? There's x cubed, x squared, x, and a constant.
Yeah,
Guys, what if I had no x squared? What would I have to write right here?
You just swap the
0.
0. 0 kind of as a placeholder type. Right? If they went straight from x cubed to x, I have to have a 0 in place of x squared. Right? I don't have that in this case. So put this bar here, put a box here. Okay. Now here's what we're trying to do. Guys, what number goes in this box? 2. Yeah. So the denominator, if it's in the form of x minus a, you put a over here. Right? Or you can say, what would I plug in x to make the denominator 0 is a different way to make stuff. And so the rule goes, you guys remember we're going to do this seesaw type approach. Right? So always drop down the first coefficient, in this case 2. Right? Then you're going to multiply across by what? How about this 2 right here? 2 times 2 is 4. And then you can do what going down?
minus, like you add the 4.
Add. Add. Yeah. So that gives you negative 3. Then multiply that by 2, you get what?
Negative 10.
Negative 6. Add going down, you get what? 1. Then times 2 is 2. Add going down, you get 0, which represents the remainder. Right. Which is to say that there is no remainder. Okay, so that's nice. So these did divide evenly. I mean, we got that from long division anyway. We're seeing it now with a different process. Okay, so I had these 3 numbers, a 2, a negative 3, and a 1. And now, I remember the original statement, I was taking something to do with x cubed divided by something to do with x. So I think my biggest term, but the highest power in x, the degree should be just 2, shouldn't it be? Because x to the 3 divided by x would be like x to the 2. And here's the coefficient. Leading coefficient is 2. We got 2x squared minus 3x plus 1.
Yeah.
Is that the answer right there?
Yeah.
Good? Yeah. Wait, is that what we got before? Here's what we got with long division. Yeah! It's the same thing! Here's long division. Here's synthetic division. It's the same thing. Can you guys know at least one of those processes by the time midterm rolls around? Okay. Now, you guys know we took a good few days to cover pretty much every single question that's going to be on the midterm. I posted all those videos. I also posted all the Kahoot links. So they're all on Google Classroom.
Okay, one more on the midterm on Google Classroom.
Well, yeah, guys, all those Kahoots we've been doing for review, those are the midterm questions. The only difference is I tweaked some of the numbers. But otherwise, the same thing. Like, here, I bet we did some kind of synthetic division and long division. Yeah, I pulled them straight off the midterm. I just tweaked some of the numbers, that's all. But we covered everything. Yeah, so make best use of your time to study what you need to study. If you're writing something down on paper, right, that's a better way to learn things. Right? If you here, you know what Principal Leggett says is good advice is if you look at your notes or you study a little bit every day, in contrast to to just studying all at once the night before? Is what's a better way to study? Like 3 hours the night before, or just half an hour every day for 6 days. It's the same amount of time, isn't it? Same amount of time.
Yeah, but I got
Yeah. No, your brain remembers it better if you study half an hour a day for 6 days. Brain remembers it better. If you do a 3 hour block, you get burned out and. Right. So you guys got this flip book. You guys see this flip book right here? Well, actually, it's not a flip book yet. It doesn't really flip so much, but that's about to change. You guys see this the staple binding on the left side? Staple binding on the left side. So everybody do this. All right, you guys got some scissors. You might have to share the scissors. I only got the heavy duty scissors today. So take the staple binding. Roll once. Roll twice. It should look like this at this point. Do you guys roll once, twice? Like that? Okay. Guys, if you have this, hang tight. Don't do anything yet. Right. If you missed a step, I'm gonna go back and show you guys that again. So you have this book. I have the staple binding on the left side.
Yeah, I got it.
I'm gonna roll a staple binding once, twice.
Okay.
Alright, so now that you rolled it once, twice, roll it something like that. It should look like this. You guys have that? Okay.
Yeah.
Now take your scissors and chop off this end bit right here.
Like the entire thing?
Just about that much. You guys see how much I'm cutting off right there? Maybe a centimeter, maybe.
Wait, Mr. Griffin, can you restart from the beginning?
Oh, I went everywhere.
Okay. Hey, so I had this booklet. I had the staples on the left side. I'm gonna roll once, twice. Right, so now it looks like that.
Yeah.
Looks like that. Okay. Then take your scissors and chop off maybe a centimeter or so. Okay. So now it looks like this, right? It looks like that.
Yeah.
Pretty even. But now unroll it. Unroll, pull it out flat. Oh, look at this. Look at that nice flip book action. How'd this one turn out?
This is tough. It's tough.
Oh yeah, that flip's really nice, doesn't it? Really nice.
This is like awesome.
Like this.
Yeah.
Like, so am I supposed to?
Yeah.
Right.
Pretty good.
Let's study with it now.
All right, so for us class, now if you have to make up something or say something, I won't stop you. But otherwise, you can apply some creativity and some math and maybe some science and figure out what a good flip book animation would be. I'll show you guys some past examples. Right. So I got bouncy ball, boing boing. Okay. Now, there's one puzzle that keeps showing up over and over and over again in your algebra book. Is height is a function of time if you throw something straight up in the air. Doesn't it usually start like negative 16t squared plus something, something, something? Right. Actually, here, I'll write down an example. So your textbook might say height as a function of time equals negative 16t squared plus, I'll just make something up, 28t plus 5. Right. This negative 16 is related to Earth's gravity. So if you were on a different planet, this would probably be a different number. This 28 has to do with how fast you threw something straight up in the air initially, like initial speed. And this 5 in this context represents maybe your initial height, like if you're standing on a platform. You guys remember that? Like some guy stands on a platform. Somebody right. Now this equation is in terms of feet in seconds. In my physics class, we usually use metric system, so negative 16 might be negative 9.8. But what I'm trying to get at here is if you want to create a realistic animation that looks believable with somebody's brain, then you want to have the location of the ball and the height, your frame by frame. Can you see how during the first second it doesn't fall out far? Next second it falls a little further. Third second. Now that gap is really growing big. Now it's bounced off the ground. So like that. Okay. So in my physics class, again, metrics units has to do with these numbers. But if you just look at this animation over here,
Well, they're not as
you
popular.
guys see frame by frame, it falls just a little bit. Ooh, now it's falling medium distance. Ooh, now it's falling a far distance. You guys see how that gap's spreading out? So that would be a believable type motion. Could you do projectile? Got projectile for you guys.
That's cool. Oh. Wow.
That's so
Whoa,
Now, how do you guys think projectiles work? Do you think that the height versus time is the exact same as it was for this one? You guys think it could follow? I bet it could follow an equation like this, math equation. Okay. But what about a different question? Not the height, but what about the lateral motion across the page? I might call that the horizontal motion. Do you think that frame by frame it's moving pretty well constant speed across the page? Yeah. Now you put those two aspects together, and you get it. The shape of the path that ball follows and that cat is a parabola. Yeah, it could be. It could trace out a parabola shape. Very good. Let's do some other ones.
How do we control?
How about this guy?
Yeah, you like it's just really cool.
How
On the plane.
about this guy?
No.
He's hungry. Oh yeah, no longer hungry. Rocket with no defense. Oh yeah.
That's right.
Projectile.
Exactly.
Oh. I should know that. Oh yeah. Ain't true.
This is gonna be too distracting.
So you guys make good use of your time. Well, check on your flip books, and I'll give you guys some points for those in the grade book.
Playboy Carl.